Hi everyone. We're going to finish up our lesson on pyramids with a brief lesson on a portion of a pyramid called a frustum. A frustum is a pyramid in which the top portion of the pyramid has been removed. Technically what happens is a plane passes through the pyramid, cutting off the top portion or removing the top portion. For a right frustum, the plane that cuts through the pyramid and the base are parallel. There are non-right frustums in which the base is not parallel to the plane, but we're not going to consider those in this course. So, a frustum is a portion of a pyramid, essentially the base of the pyramid, in which the top's been removed. The frustum itself has a top base, has a bottom base, and sides that are trapezoids. As we do with pyramids and other three-dimensional figures, we're going to consider the volume and the surface area. There are formula for frustum, but I find it easier to think, rather than formula, to think of an overall strategy. Think of how the frustum is formed. The frustum begins with a pyramid, and the top portion of that pyramid is removed. So the volume of this frustum is going to be the volume of the overall pyramid, so the volume, we'll call it V1 of the overall pyramid, minus the volume of the smaller pyramid. So that's the overall strategy. Find the volume of the larger pyramid, find the volume of the smaller pyramid, and then the volume of the frustum is equal to the volume of the whole pyramid minus the volume of the smaller pyramid, the top portion. Now, that sounds easy in principle, but it's a little bit harder because with a frustum, if you think about it, you see a frustum. Here's the problem. This is similar to problems you'll see in class on homework. The problem says find the volume of a right square frustum. That means the top and bottom portions are squares. With bases of lengths 4 units on the bottom, 2 units on the top, and an altitude of 6 units. So you see the problem. We don't know the height. We'd like to find the volume of the whole pyramid from which this frustum was formed, but we don't have it. So we've got to find, how can we find what the original pyramid looked like before the top portion was removed? To do that, what we want to do is we want to look at a side view of the frustum. So here we are standing at the side and looking at the frustum from the side. This bottom base is 4 units. This top base, the blue dashed line, is 2 units. And the height from the top base to the bottom base is 6 units. To find the volume of a pyramid, remember volume is equal to 1/3 times the area of the base times the height. We want to find the volume of the entire pyramid. We know that's going to be, this will be, as we sort of being consistent with what we did before. Let's look back. That what did we call that? That was V1. Okay, so V1 in this case is 1/3 base times height. Area of the base, it's a square with sides of length 4, so that's 1/3 times 4 times 4, area of the square, 16, times the height. Now how are we going to find the height? The height would be the total height of the pyramid, which is right here. It's the whole height. Fortunately, what we have, if we look at the side, we have 2 similar triangles. So similar triangle 1 is the top portion, the portion that was removed. Similar triangle 2 is the entire pyramid. So what I'm going to do is I'm going to set up a proportion to find that height. If I call the top portion x, then I know the height of this pyramid is equal to the altitude from base 1 to base 2, which is 6, plus x. So setting up the proportion, I know that the height of the smaller triangle on the top, which I'll say is x, over, and again, proportional sides, over the base of the smaller triangle, which is 2, equals the height of the entire triangle, which is 6 plus x, over the height of the over the base of the smaller triangle, or of the entire triangle, which is 4. Cross multiplying or clearing your fractions, as Dr. Caston likes to say, 4x equals 2 times 6 plus x. So 4x equals 12 plus 2x. 2x equals 12. So x equals 6. Now, we kind of got lucky here. In this case, the bottom half of we essentially did cut the frustum in half. The height from the bottom base to the top base is 6. The height from the top base to where the top of the pyramid used to be is also 6. You could kind of see that because what I did was I cut the base in half. The base started out as 4 on the bottom. It's now 2. It took 6 units to cut it in half, so it will take another 6 units to eliminate that length entirely. Nonetheless, the overall height of that pyramid is 12. H is 6 plus x, so 12. So this will be 1/3 times 16 times 12. 3 goes into 16 4 times. So that's going to be 48, and this is a volume, units cubed. Now, the volume of the smaller pyramid, which I'll call V2, also equals 1/3 area of the base times the height. But this smaller pyramid, which is the one that was removed, V2, we removed this top portion right here. So that has a base of 2 units, or the base length of 2 units. So the area of the base is 4, 2 times 2. So I have 1/3 times 4 times the height of that top pyramid, which was 6. 3 goes into 6. 2 times 4 is 8 units cubed. So the volume of this frustum, which equals the volume of the entire pyramid minus the volume of the smaller pyramid that was removed, which equals 48 minus 8, which equals 40 units cubed. Okay. Now, let's do the same thing for surface area. The surface area of a frustum, again, what we're going to do is we're going to use this overall strategy. Think how the frustum was created. To create the frustum, we remove the top portion. So what we're going to do is we're going to take the surface area of the entire frustum. Okay, well, I don't know if I like that portion. That may get us in a little troubles. You'll see in a minute. Let's think about it a different way. This frustum has a top base and a bottom base. They've got to be part of the surface area. So my surface area of my frustum is going to be the area of the big base down here, which I'll call big B. All right, so B, big B, plus the area of this little base up here, which I'll call little b. So I've taken care of the area of the bases. Now what I'm going to do is I'm going to look just at the sides. With the sides, what I've done, the sides are triangles. And for these sides, what I have done is I've taken off the top portion of the triangle. So what I need to do is find, we'll call this the area of the entire triangle, T1, the area of the smaller triangle, T2. So what I'm going to do to find the surface area is I'm going to find the surface area of one of these sides, which is T1, the area of the entire triangle, minus T2, the area of the smaller triangle. But I've got 4 of those, so I'm going to multiply that by 4. So in general, again, strategies are, for surface area, let's add up the areas of what we have. What we have is we have a bottom base B, a top base little b, and then we have 1, 2, and then back here 3 and 4, essentially trapezoids. Those trapezoids we could find by taking the area of the whole triangle minus the area of the top triangle that was removed. So again, let's look at an example. This is the same example. Now what we've already found from what we did before when we were finding volume, we know that this portion, the height is 6. This top portion we found was also 6. We know this bottom base is 4. This top base is 2. Now, these triangles, or the triangles, essentially the triangles that were formed, what we need to know is we need to know not the side lengths, not the lengths along the edges, but we need to know essentially the slant height. And if you look at it, this is a side view. The slant height would be the height along this slanted edge, so that would be our L's. So again, we can use similar triangles. We've got this little L, let's see. We know that 6, we know that this base is 2. We know that these are right triangles. So with right triangles, this would be, this is 2, sorry, that's a right triangle, there you go. So what I have is I got 6, half of this base, I'm going to do a little erasing here. So if the whole base is 2, I know that half of the base is 1. So this base right here is 1. If the whole base is 4 on the bottom, half that base is 2. So I can find the entire length of that triangle. I know that L1, I'll say L1 for the entire triangle, L2 for the top triangle, L1 squared by the Pythagorean theorem equals 6 squared plus, which is not 6, but L1 squared, since I was looking at the smaller one, L1 squared equals the entire height, let me go back to my pen, equals 12 squared plus this leg squared, so I've got this right triangle, which is plus 2 squared. 12 squared is 144 plus 2 squared, which is 4. That equals 148. So L1 squared equals the square root of 148. L2 squared equals, and L2 is this top triangle, so what I'm looking at is I'm looking at that little portion right there. So L2 squared equals the bottom squared, which is 1, so 1 squared, plus this other leg squared, which is 6 squared. 1 squared is 1, 6 squared is 36, so that equals 37. So L2 equals the square root of 37. I think now I'm set to go. If I look at my triangle, so what do my triangular sides look like? What I had was, before I removed the top of that frustum, what I have is I've got a triangle with base 4. The height of that big triangle, we said, was the square root of 148. Then I removed the top portions of those triangles, those little portion on the top. Boy, not a very straight hand, but you get the idea. That bottom triangle, that top triangles we removed, had a base of 2, a height of the square root of 37. So the overall surface area is going to be the area of the bottom base, which is 4. It's a square with side lengths 4, so 4 times 4 is 4 squared, plus the area of the top base, which is 2 squared, plus what I've done is I take the area of the big triangle, which is 1/2 times the base times the square root of 148 minus the area of the little triangles that were removed. When we remove the top, of this frustum, remove these little triangles from the surface area. So that would be 1/2 times the base, which we said was 2, times the height, which is the square root of 37. Now, that's the area of one of these. Oh, there we go. Of one of these trapezoids. But I have 1, 2, 3, 4 of them, so I multiply by 4. So doing a little simplification here, which I think I can do, this is going to equal 16 plus 4 plus, I'm going to distribute my 4. 4 times 1/2 is 2. 2 times 4 is 8, so 8 square root of 148 plus, again distributing my 4. 4 times 1/2 is 2. 2 times 2 is 4, plus 4 times the square root of 137. Now, this is an area, so I would add that up. The area would be units squared. Finally, just a quick note about, what would happen if your frustum was not regular. In that case, for the volume would still be the same. You would find the height of that, the height that's missing of the pyramid. You would then take the volume of the entire pyramid the way it was before the top was removed, find the height, or then take away the volume of the little portion that was removed. To find that portion that was removed, again, we can look at this from the side. What we've got from the side, let me go use let's do green pen for this. We've got 6 here. We've got, I'm looking at it from essentially from this side right here. I've got 10 on this base. I've got 6 to go from there to there. We'll call this portion of what was removed X. And again, you have similar triangles. You'd have that the top portion, X is to 6, height is to base, equals the overall height, X plus 6, to the base, which we said was 10. Cross multiply, find X, and then you found the height that was removed. So you could do that, find the volume of the entire frustum, or entire pyramid, take away the volume of this top portion. Where it gets a little tricky is when you have, for this type of non-regular frustum, you notice that you've got two different slant heights. Because on one slant height, let me erase this. On one slant height, you've got a triangle looking at it from, and again, from the green side, we've got a height of 10. So we're looking at it from this direction. So what we'd be finding is we'd be finding this slant height over here. That's 10. We know that the top portion is 6. When we found the height, we could find this height and the overall height. And so with 6 and 10, we know this is 5, this is 3, and use Pythagorean's theorem to find that height and the whole height. Now, the other way we have to do this, the other portion, we have to look at the pyramid from that side. So what we'd see is we'd see a top portion of length 6. Length 4. Let me get back. We'd see a bottom portion down here, which again we can, if it goes from 6 centimeters to 10 centimeters, that's a reduction. So we could use proportions to get this bottom portion. 6 is to 10 equals 4 to we'll call it y. 6y equals 40. So y equals 40 over 6th on the bottom. In other words, what you've got to do is doing the same thing. The heights don't change, so these heights will be found as before. And you have to use similar triangles and Pythagorean theorem again to find this slant height and the other slant height. Again, for non-regular frustums, just like non-regular pyramids, you have two different slant heights.